Good morning, students. Today I am going to discuss about Andrews isotherms of carbon dioxide. Andrews plotted the graph, that is pressure versus volume curves of that is a gas at constant temperature called that is isotherms or isothermals. The series of graphs. What is mean by isothermals or isotherms means a series of graphs plotted pressure against volume at constant temperature, a particular constant temperature called that is the isotherms. Iso means that is same and therm means temperature. At particular temperature, the keeping the temperature constant, and a graph is plotted pressure versus volume, and that curves called that is the isotherms or isothermals. They may ask for what is mean by isotherms means you have to say that is at constant temperature the curves are obtained pressure against volume. For ideal gas, PV is equal to nRT and the product PV is constant if it is T is fixed. Because the PV is nothing but product, it will be like a constant. When the temperature is fixed at 25 degrees Celsius or 35 degrees Celsius, then it will be converted into Kelvin and it will be fixed, and therefore it is remains constant. Hence the isotherms would be a rectangular parabolas. The curves will be obtained rectangular parabola. For an ideal gas, PV is equal to nRT and the product is constant if T is fixed. Hence it is the same, that is I explained here. It is once again it is taken here. Then Andrews plotted a isotherms of carbon dioxide for series of temperatures. The different temperature by keeping a constant, and Andrews plotted the series of PV curves, and he got that is a different type of the curves. We say that is in the figure. There are three curves, three types of the curves will be there. One is the above the 31 degrees Celsius and below the 31 degrees Celsius at the 31 degrees Celsius, because 31 degrees Celsius is nothing but critical temperature, critical constant or critical temperature. Now you see here, this is the actually at keeping constant particular the temperature. These are the at 48 degrees Celsius. It is just as a ideal gas behavior. This is the curve that is related to ideal. But other gases, they can be deviate here. The 35 degrees Celsius, 35.5 degrees Celsius, it will be just like a rectangular. Again, that is at 31 degrees Celsius. It is a rectangular parabola, like parabolic curve will be takes place. It is a rectangular and parallel to the y-axis. This will be takes place, and 31 degrees Celsius, it is nothing but it is a critical point. Critical point here, F is nothing but a critical point. At above which, above this 31 degrees Celsius, all gases remains gaseous state, and gases cannot be liquefied even though high pressure will be applied. And below that 31 degrees Celsius, the all gases remains that all gases is converted into liquid, and there is no gases present in the below 31 degrees Celsius, and such temperature is called that is a liquefiable temperature, or it is also called as a critical points or critical temperature. Thus F is called as a critical point. At critical temperature and pressure, the gas becomes identical, because the gas at this temperature, no gases became identical. We cannot be say either it is a liquid state or in the gaseous state. We cannot be say it is an identical behavior. It and that identical behavior state, no, that is called as a critical state. The smooth merging of the gas with its liquid is referred to as a critical phenomena. Andrews demonstrated the critical phenomena in the gases, taking example for carbon dioxide. He explained that is by taking the example carbon dioxide gas. Okay, here I have to explain here. This is the critical temperature is nothing but 31 degrees Celsius, and we have to explain at the 31 degrees Celsius what happening, and above the 31 degrees Celsius what happening, and below the 31 degrees Celsius what happening. These we have to discuss one by one here. Therefore, isotherms above the 31 degrees Celsius, what happened here? The isotherms at 40 degrees Celsius, a rectangular parabola approximates to the isotherms for the ideal gas, because here just like suppose we are increasing, this is the dotted line, therefore it meet to the y-axis and it will be meet to the that is the x-axis, therefore it say that is a rectangular parabola, and this is the just like a rectangle, it rectangle triangle, it will be like that it will be form, and this curve will be a similar to that is nothing but ideal gas. It this like curve it gives that is a ideal gas behavior, but apart from this this point, but below this temperature they say that is a they are saying just simply it is a deviation will be takes place, therefore we say that is a so all other isotherms below 31 degree that is above 31 degrees Celsius, the region above which isotherms at 30 degrees Celsius carbon dioxide always exist in the gaseous state. Then isotherms below 31 degrees Celsius, what happen? Isotherms below 31 degrees Celsius are discontinuous. Discontinuous means it is at one place it is there is no uniform phase. One point at it will be liquid and another point will be a gaseous state. Therefore, it is a discontinuous phase will be takes place. Therefore, the below that is below 31 degrees Celsius, they are isotherms are discontinuous. For example, the isotherms at 21 degrees Celsius consist of three parts. At 21 degrees Celsius, this is the 21 degrees Celsius. This consists of that is three parts. First one is goes to that is a curve AB. AB means here from we say that is A and B. What happened here? These are all our gaseous state. Here it became a liquid state. Clear? Therefore, as this is the volume, no, here volume is high. At a point, the volume of the gas will be high, and pressure, because of that is pressure increase. No, pressure will be here. Bottom means around that is 55 or 55 around that is atmospheric pressure. Therefore, here the gases will be remains in gaseous state. As the pressure increases, then volume will be decreases. As the pressure from A to B increases, the volume will be decreases and comes here becomes, and therefore liquids there is gases, no, they are compressible, they are compressed, they come closer, and it reaches that is a B point, and that can be explained here. A curve PV, curve for gaseous carbon dioxide along AB, the volume decreases gradually with increase in pressure. At the P volume, that suddenly due to the that is decreases due to the formation of the liquid carbon dioxide having a higher density. Here, therefore, we say that is when it is liquid that is gaseous, no, it comes here, and the liquid that is density which became a high and it became a liquid state. It converted into liquid state at B point. Then curve BC, we have to explain that is a curve that is a BC, horizontal BC. Along the horizontal part BC of the isotherm, the liquefaction continues while the pressure is held constant. At the C, all the gas will be converted into liquid state. What happened here? From B to C, we are it is making the pressure remains constant. As the that is a pressure constant, and we are making that is cool, all liquid will be converted. That is became a compressible, and all that is the gases will be converted into liquid state from B to C at constant pressure. This will be horizontal line. It say that is conversion of that is all gases into converted into that is a liquid state BC. Then the vertical CD. This part of the isotherm is the fact that the PV curve is called as a liquid carbon dioxide. This almost vertically, since the liquid is not very compressible. Therefore, we say that is here from B to C is the compressible liquid. Compressing it will be takes place. All that is molecules comes closer, and it became a liquid state. And further up to C, after further that is making that is applying the pressure, even the pressure, the liquid cannot be compressible. It cannot be compressed, and the volume cannot be decreases. it remains that is a parallel to the y-axis. This is the CD curve is nothing but it is parallel to x-axis, parallel to y-axis, and it indicate as there is no compressible liquid will be takes place. Then this is about that is below below isotherm below 31 degrees Celsius. Now coming to that is isotherm at 31 degrees Celsius. And it is noted that above 31 degrees there was no possibility of liquefaction of the carbon dioxide gas. However, great pressure is applied. Even though high pressure applied, the above 31 degrees Celsius, there will be no possibility to formation of liquid. The gases remains gaseous state because the 31 degrees Celsius is the critical temperature. The critical temperature of the carbon dioxide, therefore 31 degrees Celsius, the isotherm EFG at a temperature called that is a critical isotherm. EFG. What is that EFG here? We say that is the EFG isotherm here. EFG. E, F and G. This is the solid line will be there, solid curve will be there. This is called as isotherms. That is a critical isotherm. The EF portion of the critical isotherms represent that is a PV curve of carbon dioxide gas. At the point F, the curve records twice with the coincides and the appearance with the liquid carbon dioxide. Here the gas and liquid have the same same density and indistinguishable. The point is called that is the critical point and nearly parallel to the vertical axis and marks the boundary between the gaseous carbon dioxide and right to the liquid carbon dioxide on the left side. Therefore, we say that is here these are the gaseous state here and this point, and here this is the again liquid state. This it is a boundary, that is a smooth boundary will be takes place. Above that, this right side, these are the remains in gaseous state, and these state, no, these are the portion will be there, the parallel to the y-axis. This will be a remains, that is a liquid state, and this is the explained by that is a Andrews. Now coming to that is a continuity of state, continuity of state of gases, that is carbon dioxide. A careful examination of the isotherms from the figure, that also explained here, from here from figures shows that it is possible to convert the liquid carbon dioxide into a gases and vice versa without any discontinuity. Therefore, there will be a possibility to making that is a discontinuity. That is the making that is a smooth merging of that is a solid liquid into solid state without discontinuity, without having any time more than one pages present on the joining the ends of the horizontal portion of various isotherms. A boundary curve, that is the HCFBI, represent the dotted line, is obtained. At the top lies the vertical point F. Therefore, here just say that is what is that continuity of state means, just like a HCFB and that is I. This is the actually dotted line, but it is not a dotted line. It is saying this is the curve, like no, just like a curve. That is this is the increasing and decreasing. This is the curve. This portion is called that is a continuity state. Continuity within the area of the boundary curve, both liquid and gaseous states are coexist, but outside the area here, this point, that is F point here, the liquid and gases will be coexist, but outside the boundary means above this portion will be a remains, that is the gaseous state, and this becomes a remains in the liquid state. And either gases alone or exist. Suppose certain volume of the carbon dioxide represented by the point X. By the point X, here X, point X means that is it should be A, that is x point means it is actually f. It is the f point on that is the 13 degrees. 13 degrees Celsius. Here 13 degrees Celsius. Isotherms A, B, C, D is heated at a constant volume of the temperature at which pressure increases to a point A. Lying above the critical pressure of the gas, let the gas be now cooled at the same pressure. The temperature and volume both will be a decreases along AH. Along AH. A to H, that is it is the temperature decreases. At C point, the temperature is at 21 degrees, 21 degrees Celsius, and carbon dioxide exists as a liquid. During the transition from that is gas to liquid, there has never been more than one phase present at any time. As the temperature is decreased from A to H, therefore we say that the volume of the gas decreases gradually till the molecules are close enough for the van der Waals forces of attraction causes the condensation into liquid state. The process of transition from that is gaseous state to the liquid state and vice versa called that is continuous state. What is meant by continuous process means a process in which any time it is at any time, at all time, that is merging liquid state to gaseous state and vice versa will be takes place, and such that is a point or such by that is taking the phenomena called that is a continuity state. And this is about that is a critical phenomena. Now I am coming to that is a derivation of critical constant of Vc, Pc and Tc from van der Waals equation. Explain the derivation of Vc, Pc, Tc means van der Waals constant, like there is a critical volume, critical pressure and critical temperature from van der Waals equation. This is the most important with the view of the examination point. The van der Waals equation can be written as P plus A divided by V square into V minus B equal to RT. Call equation number 1. Then just you have to multiply equation 1 one bracket by other bracket. Therefore we get that is a PV minus PB plus A divided by V, it is just multiplying, minus AB divided by V square minus RT, that is RT is taken after left side, it became a 0. And this equation now divide by V square. What happened after dividing V square? I will get that is a P divided by V minus PB divided by V square plus A divided by V cube minus AB divided by V4 minus RT divided by V square. This is equal to 0. Then for this equation you have to take that is the LCM of V4. LCM taking that is LCM V4, that is the highest per degree. Therefore we will get that is a PV cube minus PBV square plus AV minus AB minus RTV square divided by V4 V to the power of 4 equal to 0. Then just take the cross multiplication, V4 into that is a 0 means it became a 0. Therefore we will get that is, we can write that is a V4, that is the numerator value equal to 0. It became PV cube minus PBV square plus AV minus AB minus RTV square equal to 0. Then that can be also written as in the form of that is a decreasing order, like a quadratic equation, A square minus BX plus C, like no. Therefore here power is 3, AX cube plus BX square plus CX plus that is a D, like that can be explained here. Therefore V in V cube form, no, the PV cube minus, this is the taking that is a common factor here, PB V square and RT V square, that I have to take, that is a minus and V square common factor, and therefore RT plus PB, this is the taken written in the bracket. Then V cube V square, then V, only V alone means AV is there, again constant will be minus AB, that equal to 0. And hold this equation, I require that is a coefficient of the V cube, no, will be a 1. Therefore, the whole equation divided by that is a P. Therefore, after dividing by P, what happen here? V cube will be get, and that is a RT divided by P plus B only, because P get cancelled, into bracket that is a V square plus AV divided by P minus, here AB both are there actually, only AB divided by P. Here extra AB is written, it is wrongly, but it is AB divided by P equal to 0. That is called equation number 2. Then we know that what is the at critical point? Critical point is nothing but V, volume of the liquid is exactly equal to critical volume. Therefore, we say that when we say that is critical volume means V is equal to Vc. Then take that is the left side. This V is equal to Vc can be written as V minus Vc equal to 0. Then taking the cubes on both sides to this equation. Then what happen? V minus Vc cube equal to 0. Then expand A minus B whole cube formula. Therefore, we can write that is a V cube means A cube minus 3 B AC square means B AC square means B means here we say that is B means Vc and A means that is a V. Okay. Therefore, 3 Vc V square plus 3 into B square minus A, that is into A means we say that is a Vc square into V minus Vc cube, that is a B cube equal to 0. That is simply, this is the expanding, this comes from like a formula A minus B cube formula expanding, and this is give that is the equation number 3. This equation is identical to the van der Waals equation at constant state, that is when P is equal to Pc, T is equal to Tc. This equation is identical. Then equation number 2 can be written as when P is equal to Pc, T is equal to Tc. Then what happen here? V cube, that is equation number 2 is written as V cube minus RTC. T means that is a Tc, P means Pc in equation number 2, that is plus B into V square plus A divided by that is a Pc into V minus AB divided by Pc equal to 0. Then equating equation number 3 and 4. What happened? Equating V cube is there, therefore it is equating same, that is coefficient 1 is there. Therefore here V cube V square, therefore we can write that is a minus 3Vc. Here minus will be there, therefore minus get cancelled. Simply 3Vc equal to RTC divided by Pc plus B will be there, get. Then again V, coefficient of V means 3Vc square equal to A divided by Pc will be get. Again Vc will get, that is a Vc cube means that is a AB divided by Pc. Therefore, after equating we are getting that is the values here. After equating the coefficient of both equations, that is 3Vc equal to RTC divided by Pc plus B. This is called equation number 5. Then by equating that is a 3Vc squared equal to A divided by Pc and Vc cube equal to that is AB divided by Pc. Call equation number 5, 6, 7. Then from that our duty to calculate that is only Vc, Tc and Pc. Then you have to solving these equations. What happen? You are just we say that is a from this equation. What is that? Here 3b from that is equation for 6 and 7, just you have to divide equation 7 by 6. What happened? Then it becomes that is a Vc square, Vc cube get cancelled, Vc divided by 3 will be get, and here Pc get cancelled, A get cancelled, B will be get. Therefore Vc divided by 3 equal to B will be get. Then after transforming we will get that is a Vc is equal to 3B. This is called equation number 8. Then substitute this value That is substitute the value from that is 6. Again we require that is here we say in this you have to put that is value from that is equation number 6. What happened? The VC you have to put here, from that PC you can calculate. Therefore PC is equal to, after putting this value here, that is 3, VC means that is 3B square, and A as it is and PC as it is. Therefore after that is simplifying, that is 3, and that is 3 to the 9, 3 square means 9, and B square, and therefore we are just cross multiplying, that is PC will be get we will get, that is what is that, the 9 into 3 means 27 B square. Therefore PC is equal to A divided by 27 B square. That is equation number 9. From the equation 5, what is that 5 equation? 3VC is equal to RTC divided by PC plus B will be there. Then substitute the value of PC from 9 and VC from 8 in equation number this, that is from 5. What happened? We will get, that is 3 into 3B equal to RTC divided by A divided by 27 B square plus B. This can be, from that we can calculate TC equal to 8A divided by 27 RB. That is BR. Knowing this equation is called as this equation. Therefore we say that is TC, PC, VC. From that we can calculate it, and from that we can also calculate, that is a van der Waals constant A and B. Therefore we are saying that is knowing the value of A and B, we can deduce from the derivation from ideal gas equation. The critical constant can be easily calculated. Conversely, since PC, TC can often be determined experimentally with the comparative case, these values may be employed to calculate the constant A and B. From A and B we also calculate from this here, the A is equal to 3VC square PC, and B can be calculated, that is B is equal to VC divided by 3 from this equation. VC 3 by this from 8 equation we can easy to calculate here, and this AB calculate easy can be calculated, and this is about, that is the van der Waals constants can be explained. So far I discussed about in this session the Andrews isotherms of carbon dioxide again, and derivation of van der Waals constant, that is critical constants from van der Waals equations. And next class I have to discuss, that is the experimental determination of constant of PC, TC by Cognard-de la Tour method. Next class I will discuss this. Okay.